Hello dear students, today I will discuss about combinations, NCR. So on the basis of NPR, we know about NPR. What is? This is the permutation of R objects. This is the ways, number of ways in which we can arrange R objects by selecting R objects, and we can arrange in order. This is the number of ways of permutation of R objects, that is arrangement of R objects in a definite order from N objects gives. Okay, and formula is what? N factorial upon N minus R factorial, where R is what? R is less than equal N and greater than 0. This is the formula for NPR. Okay, from 5 objects we can select 2 objects. In how many ways? Gives the answer. NPR is the formula. This gives selecting and arranging in a definite order of R objects from N objects. Okay, this is the, in permutation there is order of the objects is countable, because arrangement in a definite order, the order is matter of manner. Okay, but for selecting, suppose from N objects we want to select R, select R objects only, order is not manner, means from 5 objects, suppose there are 5 objects A, B, C, D, E. Now, selecting 3 objects from these 5 objects, selecting. So, we can select A, B, C or B, C, D or C, D, E, but only selecting method, just like this. Suppose, take only 3 objects are there. Okay. How many objects? 3 objects. I'm selecting 2 objects. So we can select AB, we can also select AC, we can also select BC. This is selecting 2 objects. But if we arrange, then in definite order, then we can arrange AB and also BA. This also can be arranged as AC and CA. And this can also BC and CB. This is the with order, or this is without order. Just you can write A first and then B, or also B then A. That is selecting. Just 2 are selected, but 2 selected and also put in a definite order. That gives 2 ways, but only selecting gives 1 ways. So here 6 ways in a definite order, and without order we get 3 ways. That means half of this. Here we know this arrangement in a definite order gives by NPR, that is 3P2. This number gives by this formula. We can see that what? 3 factorial upon 3 minus 2 factorial equals to what? 3 into 2 into 1 upon 1 factorial equals to 6. There are 6. Clear? Now 2 are selecting. So here 3, if we divide it, or if we take only this selection, there are 3. 3 is multiplied by 2 factorial. Then this is equals to what? We see also 6. 6, that is N3P2. So this is in order, or only 3 is without order. 3 can be found how? 3. This is the selecting ways. 3 is equals to what? 6 upon 2 factorial. 6 means 3p2 upon 2 factorial. Clear? That is, and this selecting 2 from 3 is denoted by C combination. 3C 2. Okay. So how? 3C2 this 3C2 is equals to 3P2 divided by 2 factorial. That is, we can write 3 factorial upon 3 minus 2 factorial, this value, and 2 factorial. This is 3C2, value of 3C2. Similarly, you can see by writing 3 out of 4. Suppose A, B, C, D are 4 objects. Select 3 from this. We can select A, B, C. We can select A, B, D. Also A, B, C, A, B, D, and we can also select B, C, D, and then A, B, C, one selection, A, B, D, another selection, B, C, D, a selection, and also ACD can be select, ACD can also be select. So DCA, this is DCA, DCB, DCB. Okay, there are 4 selection, and these 3 can be arranged in how many ways? 3 objects can be arranged in how many ways? We know 3p3 is equals to what? 3 factorial. This is the in order. 3 out of 3. 3 factorial upon 3 minus 3 factorial equals to what? 3 factorial upon 0 factorial equal to 3 factorial equals to 6 ways are there. How many ways are there? 6. Because A, B, C. Okay, A, C, B. Then B, C, A. 2, 6 ways. So this can be arranged in 6 ways. This can be also arranged in 6 ways. This can be also arranged in 6 ways. Can be also arranged in 6 ways. How many are selected? 4 into 1, 2, 3, 4. So So 4 times are there, that is permutations in order. How many times? 4 times. So 4 into 6 equals to 24. Clear? So this can be also found by which? 4c, 4p, 4p, 3. 4 factorial upon 4 minus 3 factorial is equals to what? 4 factorial upon 1 factorial equals to 4 factorial equals to 24. That is 4p3. This is the selection and put in a definite order. Now, only selecting. Don't care about order. That is, how many ways are there? 1, 2, 3, 4. 4 ways are there. So, 24 divided by 6 gives what? 4. 6 means 3 factorial. 6 means 3 factorial. 24 is what? 4p3. 6 means 3 factorial. And this 4 means this is the combination. Out of 4 taking 3. So this is 4 out of 3 only selecting technique. It is 3 out of 4. Okay. Here 3 out of 4 only selecting. Or here 3 out of 4 and also what? Put in a order. Divided by this gives this. That is here what? 4c3 equals to 4p3 by this. That means just we write 4c3 equals to 4 factorial. 4p3 means 4 factorial upon 4 minus 3 factorial into 3 factorial into 3 factorial. Just we see 3c2 3 factorial by 3 minus 2 factorial into 2 factorial. 4c3 4 factorial upon 4 minus 3 factorial 3 factorial. So just like this we can find formula 4 means n. CR, selecting R objects from n objects, is selecting, not in a definite order, only selecting. We can write 4 factorial, 3 factorial, n factorial, n factorial upon 4 minus 3, 4 minus 3, 3 minus 2 means n minus r. N minus r factorial. Clear? Into r factorial. What? 2 factorial, 2 factorial, 3 factorial, 3 factorial. So this is combination formula. This is the selecting, only selecting, not a definite order. This is selecting and put in a definite order. Permutation, this is combination. Okay, NPR and NCR. Clear? This NCR gives number of ways in which we can select some objects from given objects, all or some at a time, just like this. Okay, here just we can prove it. NCR equals to NC n minus r. By using this formula we can prove it. Okay, NCR equals to NC n minus r, because if we put it in formula, then what? N factorial upon n minus r factorial into r factorial. So here n factorial upon n minus r factorial into n minus r factorial. So here we see that n cancel, r minus minus plus r factorial. So this gives what? N factorial upon r factorial into n minus r factorial. So both are same. So this is a formula. Also, that is NCR equals to NC n minus r. Okay, and also NC0 equals to, 0 means what? 0 factorial. NC0 means what? N factorial upon n minus 0 factorial into 0 factorial. 0 factorial 1. So this is n factorial, cancel 1, 1, 1. This is 1. Clear? NCN, n factorial upon n minus n 0 factorial and n factorial. So 1, this would also 1. Clear? NC1 equals to what? NC1 equals to n factorial upon n minus 1 factorial into 1 factorial. So n can be written n into n minus 1 factorial. So this cancel equals to what? N. So NCR solving very simple. Okay. So NCR gives number of selection, ways of selection, R objects from n objects, and these are the formula. We can solve questions by using this. This is the combination. On the basis of formula of combination NCR, just we have to solve exercise 7.4. So we know NCR is equals to what? N factorial upon n minus r factorial into r factorial. This is the NCR, value of NCR. It can be solved. Factorial n upon n minus r factorial. Here r is less than equal n is greater than 0. Okay. This is NCR formula. Combination. We also know that NCR equals to NC n minus r. Okay. These two formula we have to use for this exercise. Okay. Combination. This is only selecting number of ways. In how many ways we can select 2 objects from 5 objects, 3 objects from 7 objects, and r objects from n objects. This is the NCR gives the number selection, number of ways of selection. Okay, so first question is given. Also here we see that NCR equals to NC n minus r is, that is r n minus r is there, and here r equals to n. That is sum of these two equals to n. So if we have this type of relation, clear? If we have this type of, this can be written also this, and if we have a relation like this, then what we can say from here, either a equal b or sum of these two equals to n. That is, this implies either a equal b or a plus b equals to n. So this is also a relation. This is also a relation. Clear? So this relation is also useful for solving questions. The first question is given here. If NC8 equals to NC2, find NC2. If NC8 equals to NC2, then find NC2. Just use this formula. Okay, we know that. You can write. We know that. This. We know that this here NC8 equals to NC2 implies n equals to 8 plus 2 equals to 10. So n equals to 10. Therefore NC2, just we have to find NC2, 10C2, 10C2. Okay. So 10C2 we have to find, that is 10 factorial upon 10 minus 2 factorial into 2 factorial. This is the formula, and NCR equals to n factorial upon n minus r factorial and r factorial. This is our formula. Okay. So using this formula we can write like this. This is equals to 10 into 9 into 8 factorial. By using factorial notation, we can write 10 into 9 into 8 factorial. Here 10 minus 2, 8 factorial. 8 factorial into 2 into 1. So we can write answer 8 factorial cancel 2 divided by 5, 5 and 45. So 45 is answer 2. 7.4 answer 45. Okay. Clear? 7.4. Now second question, determine n if. Here also we will use the formula of NCERT for question 2. For question 2, here it is given that at 2NC2 ratio NC2 equals to 12 ratio 1. First question, given here given 2NC3 ratio NC3 equals to 12 ratio 1. This is given relation. Okay. Clear? We have to find the value of n. So 2NC3 upon NC3 equals to 12 upon 1. Just we have to find value of n. NCR is formula is there. Just apply formula here. 2NC3 by using that formula 2n factorial upon 2n minus 3 factorial and 3 factorial. Okay, upon n factorial upon n minus 3 factorial 3 factorial. Okay, so this is equals to 12 by 1. Clear? Here just our target is finding value of n. So here just write 2n factorial can be written 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 factorial, because of here is 2n minus 3 factorial upon 2n minus 3 factorial into 3 factorial. This is upper part, and lower part this go to the numerator and this is denominator. So into n minus 3 factorial into 3 factorial upon n factorial. N factorial can be written n minus 1, n minus 2, n minus 3, just like this, and this is equals to 12 by 1. Now here we see that 2n minus 3 factorial this cancel and n minus 3 factorial this cancel. 3 factorial cancel. So here we get 2n minus 1, here 2n minus 2, 2n minus 2. So 2 can be taken common, n minus 1. This cancel, and here n minus 3 cancel, 3 cancel. So upon n minus 1, n minus 2, n minus 2, up to n minus 2. Okay, this. So here we see that n minus 1 cancel, n cancel. So very simple. This is equals to 12 by 1. So we can solve. After this line, n cancel, n minus 1 1 cancel. So 2 into 2 4 into 2n minus 1 upon 4 2n minus 1 upon n minus 2 equals to 12 upon 1. So 8n minus 4 equals to 12n minus 24. Clear? So here we can see that 12n minus 8n 4n equals to 24 minus 4 equals to 20. So n equals to 5. N equals to 5. Okay. So question 7.4. First 5. Then 4. Clear? So here you can also solve it. Second is given just like this. Given 2nc3 11 ratio 1. Okay, 2nc3 ratio nc3 11 ratio 1. So you can get from here value also. So do it from yourself. Okay. Now take question third. Take question third. This is related to combination questions. So see here. How many chords can be drawn through 21 points on a circle? Question 3. Okay. Question 3 is what? How many chords can be drawn through 21 points on a circle? Suppose we have a circle like this. How many points are there? 21. 21 points. 21 points on circle. Take 21 points on circle. Okay, just points take on a circle. How many chords can be drawn? For drawing a chords, we require 2 points. Order may be anything. That is selecting 2 points. By selecting 2 points, we can draw a chord. Any 2 points can be selected. Any 2 points can be selected. So selecting 2 points out of 21 is the number of chords. Okay, just you have to discuss it for writing answer. We know that a chord can be drawn. A chord can be drawn by joining any 2 points on the circle. So for making we require 2 for making chords. For making a chords we require 2 points. Therefore, the number of chord can be drawn using 21 points on a circle can be found using NCERT formula as selecting 2 points out of 21 points. That is, so number of chords is 21C2 equals to 21 factorial upon 21 minus 2 factorial into 2 factorial. So it can be solved 21 into 20 into 19 factorial upon 21 minus 2 19 factorial into 2 into 1. So 19 cancel, 20 10 210 210. This is the number of chords. Number of chords, that is selecting 2 points out of 21. So 20C2 210. This is the answer of third. 7.4 third 210. Okay, so very simple. Now question 4, you have to write just like this. Okay, by writing in details. Take question 4. Question 4 is what? In how many ways can a team of 3 boys, 3 girls can be selected from 5 boys and 4 girls? Just we have to make a team 3 boys, 3 girls from 5 boys, 4 girls. Just selecting matter, not order is not no matter. So only selecting. So 5 boys, 4 girls, so 3 boys, 3 girls. They are here 5 boys and 4 girls. So for making team of 3 girls and 3 boys, just select 3 boys from 5 boys. Number of ways in which 3 boys can be selected out of 5 boys is what? 5C3. Similarly, in 4C3 is the number of ways in which in 4C3 is the number of ways of selecting 3 girls from 4 girls. So by using multiplication principle, the number of ways in which team of 3 boys and 3 girls can be formed is given by 5C3 into 4C3. 5C3 into 4C3. It can be solved. 5 factorial upon 5 minus 3 factorial into 3 factorial into 4 factorial upon 4 minus 3 factorial into 3 factorial equals to 5 factorial upon 5 into 4 into 3 into 2. 5 into 4 into 3 into 2 factorial upon, here 5 minus 3 2 factorial into 3 factorial. Here 4 means 4 into 3 factorial upon 4 minus 3 means 1 factorial into 3 factorial. So here we see that what 3 cancel, here 2 cancel, and 1 2 factorial cancel, and here 4 3 factorial means here we can write this 3 into 2. Okay, so this cancel, this cancel, this 3 cancel, this 2 5 to 10 10 40 40. This is equals to 40. So 440, 7.4 440. Okay, 440. Very simple. So here main thing is that we require 3 boys out of 5 boys, so 5C3 are the selected way of selection, and similarly 4C3 is the way of selection of 3 girls from 4 girls. So both are simultaneously, of course. So by multiplication principle, the number of ways is multiplied by these 2. We can calculate 40. This is the answer. Okay, 40, 7.445. Now take question 5. Here question 5 is given just like, find the number of ways of selecting 9 balls from 6 red ball, 5 white ball, red, white and blue. 5 red, 6 red, 5 white, 5 blue balls if each selection consists of 3 balls of each color. Number of ways of selecting 9 balls out of. So simple here. First of all, decide. We have to select 9 balls. But there are, how many colors are there? 3 colors. And of each color, 3 balls are required to select. At least 3 balls. So in 3 places, 3. So here 9 balls we have to select from 6 red, 6 black. Okay, so just I will discuss in very short. 9 balls requires selecting from 6 red ball, 5 white ball and 5 blue ball. Means we have 6 red, 5 white, 5 blue ball. We have to select 9 ball from this. Condition is that from each 3 ball, at least 3 ball will be, at least not as 3, at least each selection consists of 3 balls of each color. First select from here, from 3 balls selection, each color. 3 balls of each color will be selected. So here we can select 3 from here, 3 from here, 3 from here, because 3 ball is required. So is, which is given by how many ways? 6. 3 from 6 into 3 from 5 into 3 from 5. This is the number of this. We can select it. We can solve it. 6 factorial upon 6 minus 3. 6 minus 3 factorial 3 factorial into 5 factorial upon 5 minus 3. 3 factorial into 5 factorial upon 5 minus 3 into 3 factorial. Just calculate it, you can get the result. 6 minus 3 means 3 factorial. Okay, so 6 into 5 into 4 into 3 factorial upon 3 factorial into 3 factorial. Here 5 minus 3 means 2 factorial. 2 factorial into 3 factorial, 5 into 4 into 3 factorial. Here 5 into 4 into 3 factorial upon 2 factorial into 3 factorial. Just we can calculate it. Okay, so 3 cancel, 3 cancel, 3 cancel. Here just we can write 3 cancel. Here 3. This 3 can be written as 3 into 2. So here 3, 6, 6 cancel, 3 cancel, 20 into here 3 cancel, 2, 10, 10. Here also 10. 3 cancel, 2, 10, 10, 100, 2000. 2000 is the answer of 5, 2000. Okay. So similarly, we can solve question 6 also. Only selecting process are there. We can also solve question 6. Question 6. What is given here? Determine the number of 5 card combinations out of a deck of 52 cards if there is exactly on ace in each combination. 5 card combination. Here, question 6. 52 cards are given in which 4 aces are there. How many aces are there? 4 aces. So here 5 card combination. We want to make 5 card combination. If there is exactly one ace in each combination, exactly one ace, 5 card, we require 5 card combination, and exactly on ace. So select 4 aces are there. So out of 4, we select 1 card. 1 ace is selected. Then 1, 2, 3, 4 card also required. So 4 cards can be selected from 52 minus 4 equals to 48. So out of 48, we have to select 4 card. This is the combination. This is the answer. Because we have to combine 5 cards, 1 and 5. 1 from S and 4 from remaining after deleting S. That is 48C. So this can be solved. So this is equals to what? 4C1 means 4. 4 upon 4 minus 3 factorial. 1 factorial, sorry. 1 factorial into 48 factorial upon 48 minus 4 factorial into 4 factorial. It can be solved easily. What? This is equals to 4 factorial is there. So 4 factorial means it is 3 factorial. 4 into 3 factorial upon 3 factorial into 1 factorial means 1. Here 48 factorial. So 48 minus 4 means 44. So 48 into 47 into 46 into 45 into 44 factorial upon 44 factorial into 4 factorial. 4 into 3 into 2 into 1. So you can solve it. Now just multiply and give the answer. Okay. So here this cancel 4 into this 4 also cancel 3 into 6. Just this cancel, divide 6 by 6. This you can get the answer. So very simple. This is the selection questions. Okay, solution ways. So this is the solution of question 6. Now take question 7. Okay. Question 7 is what? In how many ways can one select a cricket team of 11 from 17 players in which 5 players can bowl? If each cricket team of 11 must include exactly 4 bowlers. So here 17 players, out of this we have to select 11 players in which 4 bowlers are required. 4 bowlers are required, na? Exactly 4 bowlers are required and 5 players can bowl. And 5 bowlers are there. Okay. Here 5 bowlers are there. Okay. 4 bowlers are required in 11 cricket team. So first of all, select 4 bowlers from 5 bowlers. 4 bowlers from 5 bowlers. Because 5 are bowlers, so 5C 4. Just 4 bowlers are taken. And then remaining players are 4 and 7. 7 are remaining. And 7 can be exactly 4 bowlers. Here, in which exactly 4 bowlers. So bowlers, 4 bowlers are selected. Then 1 bowlers out of 5 bowlers are subtracted minus 5 equals to 12. So this remaining 7 are selected from 12 bowlers. So this is the ways. This is the answer. Clear? 4 bowlers selected from 5 bowlers and 5 bowlers are subtracted from here 12. So remaining 7 are selected from 12. So this can be solved by using formula 5 factorial upon 5 minus 4 factorial into 4 factorial into 12 factorial upon 12 minus 7 factorial into 7 factorial. Just calculate it and you can give the answer. Okay, this is selection process. Now take question. This is the question 7. Okay. Now take question 8. A bag contains 5 black, 6 red balls. 5 black balls, 6 red balls. Determine the number of ways in which 2 black, 3 red balls can be selected. Very simple. Okay, just you can do it from yourself. Here in question 8, what is given? Here it is given that in a bag there are 5 black, 6 red balls. 5 black balls, 6 red balls. Clear? 5 black balls, 6 red balls. Determine the number of ways in which 2 black, 3 red balls can be selected. 2 black, 3 red. 2 black from 5, 3 red. So this is the number. We have to select 2 black ball from 6 ball. 2 black, 3 red. 2 black from 5, 5C2. 3 red from 6, this. This is the selection process. Okay. So 5 factorial upon 5 minus 2 factorial into 2 factorial into 6 factorial upon 6 minus 3 factorial into 3 factorial. Just you can solve it. You can give the answer. Okay. Question 9 solution. Now last question is 19. Okay, question 19. Question 9, 19, no, 9. Question 9. In how many ways can a student choose a program of 5 courses if 9 courses are available? Very simple question. A student want to select 5 courses. If 9 courses are available and 2 specific courses are compulsory for every student. So 2 are compulsory. So remaining 3, you have to select it from 7. From remaining 7. Okay, there are 9 courses available. A student have to choose a program of 5 courses, of which 2 are essential, 2 are compulsory. So for choosing 5 courses, it is only required to choose 3 out of 7 courses, because 2 are compulsory. So 9 minus 2, 7. Out of 7, just you have to select or choose 3 courses, that is 7C3, that is 7 factorial upon 7 minus 3 factorial into 3 factorial, 7C3. This is equals to 7 into 4 into 7 into 6 into 5 into 7 minus 3 means 4. 5, 6, 7, 4 factorial upon 4 factorial into 3 into 2 into 1. So here you can see that 7 into 4 cancel, 3 into 6 is cancel, 35. 7C 3. Okay. Clear? 35. 35 is the number of ways in which the student can select 5 courses where 2 are compulsory from 9 courses. Okay, 35 is the answer for question 9. 7.4, 9, 35. Okay. So, for each questions you have to write in details and very clearly and give the logic and then write. So solve all these questions of 7.4 exercise in your copy and send me at least solution of 4-5 questions to me for your attendance. Okay.